Good evening, everyone. This is Product Tank Bellevue. I hope you can see us. This is our first time using StreamYard. It's a great tool that's been provided by Product Tank. And we are being streamed live here on YouTube. This broadcast is being recorded and will live forever on the Mind the Product YouTube channel. So we're going to give it just 1 more minute for a few more folks to join. During the presentation tonight, you will be able to ask all your questions using the chat. And Stephen and I will be your moderators. This is very conversational, despite the fact that we can't see your faces or hear your voices. We do want to preserve a little bit of the informality of this and offer conversation. So please feel free to chat. And while we're waiting, just a little icebreaker here. In one word, how would you describe your day today?
Oh, gosh. I'm going to say eventful.
Eventful. That's good. I was going to say chaotic.
Chaotic.
Which is a different take on eventful.
That's fair.
Stephen, do you want to share how your day was?
I actually took today off.
Oh, well, that's fantastic.
There you go.
Time off. That's a word to describe today.
Great.
Time off.
Yep.
Leisurely.
Leisurely. All right. So for those of you out there, if you want to just put in the chat 1 word to describe your day, we can get a sense of what the mood is like out there in YouTube land. And I think we should get started. So yeah, just to kick us off, just want to give a little introduction to Product Tank. So Product Tank is a community of product people. We have chapters in 200 cities around the globe, and this event tonight is organized by Product Tank Bellevue. We host virtual events every 6 weeks, and we have started hosting some in-person happy hours to fill the time between the virtual meetups. We value storytelling, diversity in thought and the community, and of course, building relationships. My name is Courtney Jacobson. I am the Director of Product at Spring Health, where we are eliminating every barrier to mental health. I'm also one of the organizers for Product Tank Bellevue, along with Stephen Wang here. Want to say hi, Stephen?
Hi, everyone. Yeah, I've been doing product management for the past 12 years. Very happy to work with Courtney to organize Product Tank Bellevue. I'm looking forward to today's discussion.
Thanks, Stephen. All right, our guest star tonight is John Mora. John is the Chief Product and Data Officer at Zephyr, a company that's focused on understanding social media content for brand advertisers. And in his role, he leads product, data science, and content policy. Prior to this role, John was the chief data scientist, where he helped create and implement a variety of machine learning models to understand YouTube, TikTok, and Facebook content. Before Zephyr, John was director of data science at eHarmony, where he helped create many of the matching models using machine learning. Must feel good to be a matchmaker. John has a PhD from UCLA in biomedical engineering and a BSc also in biomedical engineering from Johns Hopkins. So welcome, John.
Thank you for having me.
Of course. Let's see.
All right, let's get started. So I assume everyone can see my screen, just judging by what I see here. So I'm going to go ahead. So thank you so much. First, thank you so much for having me. Really excited to talk about a topic that's near and dear to my heart, leading data-centric product teams. So let's go ahead and get started. So I love to show this image to start. I don't know. I'll take a quick poll of the audience. Does anyone know what you're looking at here? Does anyone want to take? I'll wait like a couple seconds, see if somebody wants to type in the chat what you're seeing here. That's okay. What we're looking at here is we're looking at a cross section of a person's midsection, but not the brain. That's a good answer. It's a good guess. It is right around your prostate. So what we're looking at here is somebody who has a CT, right, computed tomography, and this is a cross section right at their prostate. And what you see on here is some different segmentations that have been drawn. Specifically, you could see a blue outline, a yellow outline. For a couple of years of my life, I obsessed over these images. From 2011 to 2013, I stared at these all the time. I founded a company called Medical Vision Systems. And what we were trying to do was to automate away the process of what's called therapy planning during external beam therapy. So if you had prostate cancer, for instance, and your doctor prescribed external beam therapy, they would strap you down on a table, take a CT of your midsection, and then find various organs or regions of interest around the prostate to make sure that when they fired high energy photons through you, they would hit the prostate and miss other areas. For instance, if they hit your rectum, you would potentially be in a colostomy bag for the rest of your life. Very bad. At the time, there were high-paid medical doctors who would go and trace these different things. You could see the femurs, the bladder, the prostate, and the rectum. And they would do this not here, but they would do this, and then they would go up a centimeter and do it again, up a centimeter and do it again. It would take them hours to do this for one patient. And so our thought process was, what if we could use machine learning to do this automatically? What if we could go ahead and take some of these segmentations of patients that have already been done, train a machine learning model that would automatically produce them? We could improve patient outcome, and we could reduce doctor time doing something quite tedious but very impactful when it comes to the outcome, when it comes to patient outcome. I had two technical co-founders at the time, and we had gotten some of these files from USC, from UVA were the two big ones. And I sat here and stared at these, and we wrote so much machine learning code, and it didn't work so well. And I remember going through the data over and over again until I found somebody who had drawn Mickey Mouse ears on one of these cross sections. And I remember just taking a step back and losing my mind. How could you draw that the prostate is outside the body? And when I went and talked to the doctor, I remember him saying, oh yeah, that's a mistake, but no one would ever use that. We would all know that that's not part of the prostate. It's fine. And my thought process was, no, it's definitely not fine. Because if we're trying to train a machine learning algorithm to detect where the prostate is, and we have data that says the prostate is outside of the body, how could that possibly, like how could that be right? And so this example always stuck with me, and it still to this day really sticks with me to really solidify kind of how I think about machine learning projects. Ultimately, this company didn't succeed, but we learned a lot, right? The number one thing we learned, ground truth is difficult to trust, right? It is really hard when somebody says, this is the data, it's labeled correctly, go ahead and do machine learning on it. No, it couldn't trust it. The other problem we had at the time was the FDA did not approve machine learning algorithms. They approved machine learning models, which our business model was that we would go and we would create a model every week. We'd retrain it as we got feedback, and the FDA said, no, you don't. We're going to give you approval per model. And by the way, it's 6 months and $500,000 every time you want to get approval. Now I think they're a little better. I haven't been in medicine in a while, but that really stuck with me. And whenever we showed these to other doctors, automatically generated ones, they were never good enough. The doctors frequently disagreed. They thought they could do it better. Even when we showed them that they disagreed with each other, it didn't matter. The systems weren't trustworthy because they were machine learning systems back in 2011. 2012 in healthcare. So I thank you so much, Courtney, for the introduction. Just a little bit about me. What was not there is I did spend 2 years in medical vision systems, founding my own company. I worked at eHarmony as the head of data science for a while, where we did algorithmic matchmaking, and I'll talk about that in a second. And then I've been at Zephyr since 2016. I became the chief product officer more recently in 2022, but I have been building data products for basically my entire career, mostly at small companies and with smaller teams. So let's talk about the eHarmony matching system. When I was there from 2013 to 2016, we had a pretty robust, at the time, machine learning infrastructure. The way that we did matching was based on 3 different parameters. The first was what we called compatibility matching. The second was affinity, and third was match distribution. Compatibility matching was based on psychographic data that predicted, should 2 people meet, get married, and will they be happy for 3 years? This was done with simple linear models by a group of psychologists that we employed. I lived in affinity matching. In affinity matching, what our value was that this is already somebody that you would be compatible with, which means you would have a successful marriage, but you may not like them. I think a lot of people have had the experience of maybe going on a date with somebody and then finding them less attractive the more you meet them, and maybe vice versa as well, finding somebody very attractive at first and then less attractive over time. We were attempting to solve for both. In affinity matching, we define success as 7-day two-way communication. So given a match was distributed, did I communicate with somebody else and they respond both within 7 days? And at the time we started, the models were trained once every 6 months. And that didn't work so well. It was a very cumbersome and long retraining process. And one of the things that I was most proud of there was that we got that down to retraining once a week. So we could keep up with changes in language and changes in images much, much faster. The third part of match distribution was an algorithm where we tried to make all the matches as equitable as possible. So everyone got at least some matches. Now, in this particular environment, what was nice is that we had consistent ground truth. Unlike in the medical example I gave before, we had to go out and find the ground truth. Every time we gave a match out, and we would give out 10 million matches a day back when I was working there, it always either resulted in 7-day two-way communication or not. So you might think, oh, well, machine learning must be easy here. Is it though? Right? We used to ask ourselves a lot, did a lack of communication really mean disinterest? It might be something as easy as the email wasn't opened. Or it might be that you just had a bad day today, and even though you opened the email, you looked at it, you were just not in the mood to talk to anyone. And we used to have lots of discussions. Are we modeling the right thing? The other thing that I love to talk about at my time at eHarmony is we would spend a lot of time with customer success. And the number one complaint that customer success always got was he was not as tall as his profile said he was. The number 2 complaint was, why did you match me with this person? And so we would really dig in hard, and the systems were yet again never good enough. Right? And I will say that the definition of good enough is very problem specific. Right? Our success rate here was low single digits, but we thought that was pretty good given the fact that we were trying to model maybe the most complex thing on earth, human love. The next problem that I'll touch on is a problem that I consult sometimes in my work. And this is an interesting company that I've been consulting with, but that does retail computer vision. So what this company does is they interact with representatives of consumer packaged goods or CPG brands who take their phones and walk down aisles and take pictures of shelves, and they ask what SKU or stock keeping unit are on the shelves. This is a large scale computer vision deployment with tens of thousands or even hundreds of thousands of classes. The fact that we can get any of these right is crazy, right? Like the amount of research and and computer vision know-how that goes in to do this and to do it accurately and to do it on the phone is a ton of research. Nevertheless, these products always change. I'll give you an example. Every year for the Super Bowl, a beer company might go into the 2 cities that represent the Super Bowl and say, we're going to make a custom beer can that's going to be on the shelf for 2 weeks. And we need you to recognize it. So we have to know of the existence of that product, onboard it, bring it into our systems, train our models on it, and do it. And by the way, it's only good for 2 weeks and then it's gone forever. We're seeing a pattern here. The first and foremost problem in this endeavor is ground truth is difficult to trust. We have an army of people who sit down and label products that look at crops of things on shelves and say, this is SKU 1, this is SKU 2, this is a Coke can, this is whatever. It's really, really hard to do well. There's a whole industry out there around how do we get humans to label things, and there's companies like Appen or Scale.ai, Labelbox that all do this. It is really hard and tedious. Training and deploying new models is a weekly ops requirement, right? If we're not doing it at least weekly, we lose out on what is out there in the world, and the systems are never good enough. Customers don't come and say, you've done a great job labeling all these, but you missed one. You hear, you missed one. And the last one I'll talk about, the last problem, is where I work at Zephyr. So Zephyr is a company that understands social media on behalf of brands. So the way that we work is if you're a brand that wants to understand where your advertisements run, the content adjacent to it on YouTube, on TikTok, and on Meta, you might work with us. And what we want to do is we want to apply a standard that the advertising industry has coalesced around on what it means to be about, to contain weapons or nudity or drugs, all the bad stuff, but also some good stuff. Is this video about sports? Is this video about movies or music? And we do that. And when we think about ingesting content, we might be given a YouTube video, but there is so much effort that goes into extracting the information from that video necessary to do anything. You have the video, how long it is, its title, its views, and all of these different things that go into influencing what this video is about. And the standard is quite nebulous. It might be easy for us to say, is there a knife in this video, right? There's off-the-shelf computer vision systems that do that. But is that knife in a cooking video? Maybe. Is that knife stabbing somebody, but it's in a Michael Myers movie, in which case, well, yeah, they are, but it's a movie. So it's really actually very nuanced and hard in how we do it. And we see the same problems over and over again. Ground truth is hard. Watching a video with a nebulous policy or observing a Facebook post or a TikTok is really difficult. And one of the big challenges we have is how to collect these ground truth labels at scale. Training and deploying new models weekly is an ops requirement, right? Content on the internet changes very fast. New challenges come up all the time. New things happen in the world. Especially, we have to be especially robust to new negative things happening in the world. And again, the systems are never good enough. People will always be able to find holes. Competitors always find holes in your models. So I want to take a break to take a step back after we've gone through a lot of these different use cases that I've seen in my career and start with a couple of definitions. What are the different types of employees that if you're working with a data-centric team that you might encounter, and what are their strengths, what are their weaknesses, and then we'll talk a little bit about team formation as well and how you might organize your teams in order to accomplish your goals. So there's a lot of people that may be involved in a data-centric product team. I broadly classified them into 3, and this is a hotly debated topic amongst my peers. Are these the right 3? What exactly are their roles? But this really helps me understand what everyone does. I've also organized this into a pyramid. Your bottom layer are your data engineers. These are people who live and breathe data sources, databases. They're in Kubernetes, they're in Kafka, they're in Snowflake, they maybe use tools like dbt. And when I think about organizing data-centric product teams, these are the people I want first and I want foremost. I do some consulting sometimes for a seed stage venture fund, and I frequently get asked, hey, we have a machine learning problem. Our first hire should be a data scientist. And I said, absolutely not, right? Data engineers produce good data, produce reliable data. And without them, you really can't produce a reliable data product. Next up is the machine learning engineer, or MLE. Think of these as the glue between the data that the data engineers produce and the machine learning algorithms. What we're seeing in industry right now is that a lot of the tools around machine learning have gotten much, much more approachable. So sometimes you don't even need data scientists. You could just get away with ML engineers because they really understand the tool chain, especially with the advent of large language models, or LLMs, like GPT. Finally, up top are data scientists. Data scientists are researchers at heart. And I've spent many, many, many years being a data scientist. And one of the hardest things about managing data scientists, I find, is the balance between allowing them to read papers, to attend conferences like ICML or NeurIPS or CVPR. These are top machine learning conferences, but still keeping them focused on driving business outcomes. And I'm going to give some strategies a little later about how we do that. But data scientists are the ones that might not produce value for a very long time, but then when they do, it could be transformative value. And so really keeping them focused on business KPIs is something that I found particularly useful when managing data scientists. So I'm going to talk a little bit about team management structures. I find this topic really fascinating because, especially as I've gotten a little farther along in my career, how we organize teams is incredibly important, and how we manage those teams to produce a successful business outcome, solving some of the problems you saw previously. I like to start with a plug. So Conway's Law is a really simple law that basically says that systems that are organized a certain way produce value based on their organization. So if you're a software team and you're organized into a bunch of different, if you're a software company, organized into a bunch of different disparate teams, you'll produce software reflective of that. This has been true in every single organization that I've ever been part of. And there's a great book, I highly recommend it, called Team Topologies. If you're interested in team organization and interplay between different teams, it's a great, great read that goes into a lot of these things. And I've actually employed it at my work at Zephyr to organize the teams in the way that I think the software should be reproduced or should be produced. So what I'm going to do is I'm going to take a couple of minutes and actually dive into how that works. So at Zephyr, we have a whole bunch of data that comes in from YouTube, from Meta, and from TikTok. These pipes are all totally different. Each one has its own unique data format, its own way of getting data in. Sometimes it's via S3, sometimes it's via APIs. For Google, it's via a BigQuery variant. And one of the things that we thought about when we were organizing these teams and thinking about how to organize everyone is we started this endeavor just with YouTube. So Zephyr used to be only dealing with YouTube, and we had YouTube-centric data pipelines. When we got business with TikTok, we had a choice to make. We could either build TikTok-centric pipelines and be parallel with YouTube. And we could say, these are the pipelines that we're going to support, and what would have been produced are two separate data pipes. And if those were the only platforms we were ever going to work on, that probably would have been the right choice, because we could have copy and pasted the YouTube pipes over to the TikTok side, done the smallest amount of perturbations, and away you go. But at the time, we had a vision in the product team. We had a vision that we were going to be on 3, 4, 5, 6 different platforms. We're still working on other ones. These are the ones that we work with now. So we bit the bullet and we said, we're going to organize our teams with one data infrastructure team. They're going to do their very best to make sure that the interface between the upstream data pipes and the data model internally is homogeneous, right? It's as similar as possible so that the downstream consumers can intermingle between TikTok and Meta and YouTube easily. Now, again, at the time, now it looks obvious, but as is a lot of decisions, at the time it was not obvious. This data infrastructure team is composed exclusively of data engineers. They live and breathe the data, and we'll talk about PM traits on that team in a second, but their whole they have very, very clear data boundaries, right? And I'm sure you've heard the phrase, with good fences come good neighbors, and really sitting down and have the product manager write the interface. These are the actual, in our case, snowflake tables where the data ends up. Here's the types. Here's how it's validated. Here's the data tests we run on it. We use soda.io, which is a fantastic piece of software to run data tests to make sure it's reliable, is worth its weight in gold. The next team that we have is a labeling team. We talked about how in Zephyr, we don't get labels as part of the business. So at eHarmony, when we gave out a match, we always had a label. In fact, at every other company that I've worked at, well, not every, almost every other company I've worked at, that's not been the case. We've had to go out and get labels to understand data, right? And so we have a whole team that does nothing but labeling. So what they do is they use software off the shelf to go ahead and render a TikTok video or YouTube video, ask questions of that video to our human review workforce, who then answer them. So this has a UI component, a UX component, and it has clear customers. The customers are, we call them the content policy team, the people doing the labeling. Data infrastructure also interacts with the team we call enrichment and deployment. This is our MLE team, our machine learning engineering team. This team is crucial in taking these very complicated business objects like YouTube videos or Meta posts or TikTok videos and extracting the information that's necessary in order to basically run our business. So they extract the MP4 from the YouTube video. They might extract frames or thumbnails. They might run transcription. They might do translation. All these different things that they do to make this data actually useful to decision on. This team is managed by the same PM that does the modeling team. And one of the things that this team is always conscious of is cost, right? Because these cost overruns, these costs can get quite high. And so making sure that they have a clear handle on the value trade-off of using these different things is crucial. And finally, all these teams feed into the modeling team. The modeling team is where our data scientists live. Their job is to ingest both labeled and unlabeled data. They're going to ingest the transcript, they're going to ingest the frames, and they're going to produce a variety of models that help emulate what the labelers have done. And we think about this organization, what we've done very purposefully is a couple of things, is that we've made it so that everyone can talk to each other via well-defined interfaces, which is key. We've clearly identified a mission for every team, right? For data infrastructure, it's get all the data and get into this format. For labeling, it's get the most important data labeled. And that actually has a lot of value in there and how do you define important, and there's a lot in there. For enrichment and deployment, it's extract all this information given a fixed budget. And for modeling, it's both produce the highest quality model that you can given the information you're provided. All of this is fed to the application. So all of this complexity is not seen by the user, right? And it's actually an open question we have at Zephyr. In our case, how much of this should we surface to the user? Sometimes our customer is very, very, very interested in how do we do the decision? Why do I trust it? Sometimes they're not. And this is an open challenge we have, is how do we get them at the right depth at the right time? So I see a question. Oh, the great question about validation sets. So I did not talk about, I'm happy to answer it. So I did not talk about validation sets. So I'll just do that real quick. So a validation set is a set of data that we take from a larger set, we put it aside, and then we train our machine learning algorithm on one set, and we say, does it work well on this other set? I call it the holdout set, same thing as validation set. That is absolutely part of modeling's job. So one of the things we talk about, and this is, I can go very deep here, I'll go a little bit, is the amount of content we have here is so vast. And when you think about the type of content that's published on TikTok and on YouTube and on Facebook, it's really a reflection of all of humanity, the good, the bad, the ugly, the everything. So our challenge is not in creating a holdout set. It's actually really straightforward to do. You can just create a holdout set. Our challenge in saying, why do we believe that the holdout set is representative of the entire distribution? When we can observe 0.00001% of all content, probably way less on these platforms, how do we build trust? And there's a couple of ways we do this. We try and do this with distributional matches and other fancy statistical techniques to not only say that that we can assert the quality of our model in the validation set, but the validation set is reflective of everything. So that's a unique problem that sometimes you have, sometimes you don't, right? If you have a whole bunch of labeled data like in eHarmony, not really a concern. But here, it's a huge concern. That's a great question, by the way. Thank you for that. The other thing I'll call out is the PM split. So we have 2 PMs that manage these 4 teams. The application is multiple teams. I'm just doing it here as one. And on the data infrastructure and labeling, I like those together for 1 PM because what it is, it's all about getting data ready to be modeled, right? And you could think of enrichment and deployment as extracting information and then hosting those models. So the cost center really is in enrichment and deployment and modeling. And then the pipes live in data infrastructure and labeling. And so that's why we decided to do that split. So we talked about Conway's law. A unified data pipeline, what we wanted to have is a unified data pipeline that was ready to onboard as many platforms as possible. Each platform in our case does contain unique nuances. I don't need to name them, you can think of them. But we tried to keep those nuances only within the data infrastructure team. The models which were aware of all content. This is another thing that we did conscientiously. When we started this endeavor, we were just working on YouTube. Our models just worked on YouTube. They were trained on YouTube data and they used YouTube specific fields. So for instance, there's a field in YouTube data called category ID, and there's 25, 30 categories that Google publishes. It was an integral part of our model. That doesn't exist on Meta. That doesn't exist on TikTok. So we made a conscious decision to, instead of doing one model that understands YouTube and a different model that understands Meta and a different model that understands TikTok, we said we're going to make a model that understands text, a model that understands images, and another model that understands transcripts. And we're going to feed those models with all the data from all the platforms. And again, it's following Conway's law. When we get that next platform, whomever it is, we have models that should off the shelf be good enough. Now we are going to have to find specific things in those platforms that will perturb the models and different nuances, but it really allows that onboarding time to shrink dramatically. And the last one, and this may seem counterintuitive, is I really try to keep the data scientists away from the raw data. Data scientists are incredibly curious. It usually is what makes them really good at their job. And the most success that I've had when managing them is giving them a constrained problem with a relatively constrained data set and say, I want you to know everything there is to know about this data. If we allow them to go upstream to the platforms, like for instance, hit the YouTube API on their own, now all of a sudden they're looking at a whole bunch of data, which they're not going to get at modeling time. They're not going to get at inference time. And so really we've built a system that says, this is your warehouse, this is your data, live and breathe here, and some other team will take care of the upstream data. So let's talk a little bit about how you manage these teams. If you're the product manager of one of them, what are you trying to do? What in my experience has worked and what hasn't worked? I'm actually going to start with all teams except for modeling. And I do see a question in the chat, which I'll come back to in a second. We run the data infrastructure team, the enrichment team, and the labeling team, just like every other dev team. So it's agile teams with 2-week sprints. They're expected to follow all the best practices around engineering, CI/CD, testing, and everything else that you would find on any kind of team management. Where I really find the difference is in the product manager. So the PM for these are different than PMs that we find on the application side that are more customer facing. First of all, they have to love technical details, right? Our PM here really likes getting in the weeds on the interfaces between these different teams and writing down the interfaces. They produce a lot of documentation that is incredibly useful here. They can easily partner with data engineering leads. Our data engineering lead is fantastic. He's very detail oriented, and our product manager and him sit all the time. I have found that detailed product requirements when working with data-centric product teams are really helpful. That doesn't mean we don't do exploration. We certainly do. We did a whole, and we sometimes our exploration is on tool choice. Should we choose tool A or tool B? But even then, writing down the success criteria ahead of time when dealing with data-centric product teams is a lot more successful that is a lot more required, I should say, than when dealing with application teams. The fourth one is something that's interesting. One of the things that I've noticed a lot when working with data-centric product teams is that people go very, very, very deep on the data, which is great. But what happens sometimes is you lose the customer, right? Is it important that the model you're working on gets a little bit better according to the validation set? Maybe, but maybe not, right? Maybe it's really expensive to add that next feature, that next model type, or whatever it is you want to add, and it's not worth it. Maybe your model has just gone a little crazy and starts producing all one value. These things are all things that I've encountered in real life. And if you're not the type of product manager, the type of person who wants to get in there and say, does this make sense? Does what I'm seeing in the data make sense? Because maybe you could hopefully write your own SQL, is just invaluable in this role. And then strong empathy for customer. That's every PM should have that wherever you are. Make sure that you're building something that customer values. So I did see a couple of comments in the chat. So does the unified model beat the individual model? Yes, it does. And it beats it by a lot. And it beats it by a lot for two reasons. One is that the modality specific models that we have now. So a modality is a way to convey information. So it could be text or images or audio, allow the model to really understand more of the why and the label to be more of the why. Instead of saying this YouTube video, somewhere in it contains a weapon, for instance, you would say this string of text, the YouTube title, mentions weapons. And that level of granularity in the labeling allows the model to be a much better. Plus, you give it breadth across all these different platforms that use language differently, use imagery differently, and it really gets better. For instance, one of the big problems our computer vision team had to overcome is that TikTok is shot vertically. And that actually has big technical ramifications when you want to understand it versus a landscape image that you would see on YouTube, for instance. But great question. How do you structure your product team? So I'm focusing here on this talk on how we structure the back-end data teams. We have a number of application teams for each line of business as well. So we have a line of business on what's called brand safety measurement. So this is for our customers who want to understand where their ads ran. They want to get a report that says, here's all the types of content that your ads ran on, and they want to use that report in subsequent advertising campaigns to make changes. Then there's a more expensive product, what we call pre-bid or the targeting product. They want to use these scores, these labels to set up the campaign. So before the advertisement is run, it's not run on inappropriate content. There's a higher price point for that and a higher level of service for that. So we have two teams that support the measurement product, customer facing teams, one for the UI UX website and one for the reporting. And then we have a whole other team that supports on targeting. All of them take data from this warehouse. So for us, again, we use Snowflake. So we have a number of blessed Snowflake tables that have all the information that these application teams need in order to deliver the value to the customer. One of the things I love about my job is that the data is the product. So really the front end team is just taking Snowflake and presenting it usefully to the customer. Do the reporting and website application teams have data roles on their teams? Sometimes. So what we do is we do quarterly planning, and every quarter leadership gets around and says, okay, what are our goals? And we solicit those all from the individual product managers. They roll up into technology goals that we talk about with the C-suite, we talk about with sales, we talk about with marketing, with customer support, we agree on it. And then we go and change the teams as necessary to accomplish those goals. We're very sensitive to team change. We don't want to change too much because that perturbs the flow, but we also want to make sure that we're adapting to the business. So the reporting and website application teams occasionally have data-centric folks, but we use Looker a lot as a tool that is front-end tool for reporting. So for instance, we'll have Looker engineers on that team. On the website team, we don't have any data folks. The expectation is that every engineer should be able to write SQL and interact with the database. So it varies some, but that's a great question as well. So I'll pivot real quick to talk about product managing the modeling team, right? And this is this is a different role. I'm not gonna say different, a different role. So I have found, and I do see another question I'll come back to in the chat, that sprints don't always work as well when you're managing data science. A lot of times there's research to be done. You know, we say, hey, for instance, our detector of adult content isn't good enough. Customers have found issues. We need to make it better. That's not something that you could just do in 2 weeks. That may take 2 hours. It may be years of work potentially. And so figuring out how to trade off research versus improvements to your product, improvements to your models is really, really hard, right? And we have a best faith effort. We asked this team to make a best faith effort to follow dev best practices. And what that means is that since they do a lot of research, they produce notebooks that maybe prove something. We don't necessarily need testing or CI/CD on those, but when we produce production level code and production level models, we do get CI/CD, we do have good testing, and we make sure that we always run our models on a holdout set so we're aware of what we're putting in production. When we think about product managers here, it's similar to the other backend data teams, but I found that a very successful product manager in modeling is able to tell great stories. If you're managing the infrastructure team, the labeling team, the enrichment team, you got to be detailed oriented, you got to be customer empathetic. But when you're managing the modeling team, when you're producing probabilistic models, probably correct models, being able to tell stories about how your models work is key. And this is something that I found is very useful in these particular teams. I'll just go back to the chat. Where do product analysts sit? So we have product analysts embedded in some of our customer facing teams. And they're looking at product analytics across LogRocket, across Pendo, and across SendGrid, excuse me. And they're combining those back to make reports. So we don't do machine learning on those. Those reports do go into Snowflake and get rendered in Looker. And we do look at those to understand how the product's being used. I was actually at Mind the Product last summer, and there was a big discussion about product analysts and should there be a separate department. We do not have the staff to do that, and it's just an interesting, I don't have a great answer for that. I have another question. In regards to a classification problem, what would be the most efficient metric to rely on? Oh gosh, I love this question. It's also a deep question. There's no one size fits all. In my experience, when I start what looks like a machine learning problem, the first thing I try and do is say why it's not a machine learning problem. Can we solve this without machine learning tools? Because machine learning is just hard. But once we know that we're in a machine learning problem, what we want to do is pick a metric that's most closely aligned with business value. And this is a very, very complicated topic. Everything from F1 to average precision to precision and recall. There's no right choice here. Mentioned earlier, you worked on some problems, and you could share what metrics. Oh, yes. So it does vary a lot, the metric we choose. So it is quite problem specific. Here on this problem, we're looking to balance F1. And the reason is because we have some customers who care a lot about precision, which means when we say something is present, is it actually present? And some that care a lot more about recall. I find all the things that exist on YouTube that are about weapons or nudity or whatever the case may be. And F1 gives us a balance of those. So just a couple more questions. What transition has been the most effective? I have found that a technical PM, I actually have both. I have 2 technical PMs on the team. One came from BD and one came from software development. And I would say that they don't have the same skill set, far from it, but I like the way that they complement each other. The one from BD is actually the best in the whole team, and I include myself, on the ability to be customer centric. I'll even find myself encouraging us to do some research, and he'll raise his hand and say, is this going to move the needle? And you're absolutely right, it's not. But he struggled and had to learn how to write SQL from scratch. And then the technical PM had to learn all the product management kind of role. And this is a very common conversion from developer to PM. You have to learn how to not write code, how to just build product. We'll come back to the last question in a second. So when we look at actually how to manage modeling teams, I have done both sprints and I've done research. So in sprints, when we think about creating, we have 2-week sprints where we do a sprint demo at the end, and every team is expected to demo the work that they did that week, or that sprint, excuse me. Sometimes the modeling team produces work and they're able to participate, sometimes not. And this is not my report. This is from a colleague of mine, Mark. But it's a template that he uses when they're doing research sprints. So you can't bound research in terms of, guarantee an output within a time, but you can guarantee a time. So what he does is he says, we're going to have 3-week sprints. And I really like this. And every 3 weeks, we're going to produce this report. And that doesn't mean we've produced a working piece of software. That means we've produced a result. That result is well documented. It has specific data that's tied to it. And what he does, and I've seen this in action and I like it, is that you get the product team together, the business team together, the engineers, and you produce this document. And what it does is it allows everyone to align on the value. It's also really nice because if it's truly novel in the field, you can use this as a submission to a conference, which can be really successful in motivating data scientists. And come back to the chat. How often does your reserve fully develop? Oh, so I would say that this is interesting. So we sometimes develop products with UI and UX on top of data science, but usually we don't. And the reason that we do sometimes in our industry is because a lot of what we're doing during the selling period is convincing people that we understand YouTube and we understand TikTok and we understand Meta, and we could do it across hundreds of millions of pieces of content. So we'll produce applications using Streamlit, which is a piece of a Python library that data scientists use to produce visualizations very quickly, that are able to move sales along. So in some ways, we can become a sales team and we become a sales add-on, and that can be quite interesting. And that could be a KPI. I don't like recording that as an official KPI because it comes and goes, but it has been quite successful. When I write KPIs for these data teams, it's very much so driven either on throughput for data infrastructure. For all teams, it's either throughput, cost, or quality. Those are the 3 things that we want to constrain. Can you do all the data you need to do? Can you do it within budget? And can you do it of sufficient quality? And can you prove that your representation of quality is representative of the universe like we talked about before? So I do want to give a couple of resources for product managers. These are 3 of my favorite. There's a lot out there. Paperswithcode.com, as its name suggests, basically gives academic papers. It references specific GitHub repos. It references different problems, and SOTA is state of the art. So if you guys ever want to know what's the state of the art for object detection, great place to look. Hugging Face is a model repository. So definitely look at them if you ever want to say what's the state of the art in various models. These are all downloadable. You can try them. And Towards Data Science, is a blog post where I read it still a lot and definitely recommend it. So you make add-ons for your customers. We have made add-ons for our customers, just coming back to the chat, although usually in ad tech, the sales process is about proving something. And then during the actual usage of the software, they dig in less. So one of the challenges that we have in product development is how much of these tools that we develop for the sales process need to make it into the product. And there's not a right answer. Sometimes it makes it in, and that requires customers, full support and productionalization. And sometimes it just stays as a sales tool to really help convince customers that we understand this data. So before I end, I do want to do an aside on large language models. So LLMs are everywhere. I'm sure that everyone here has heard of them, and I would be shocked if you guys haven't tried at least some of them. This is a big list that I put together a while ago. It's 3 weeks old, so I'm sure it's terribly out of date. But these are all the different models, middleware, not all, some of the different models, middleware, and products that I've come across. And I like to give this list because it really helps quantify what's going on with this LLM craze right now. Large language models are not new to data scientists. We've been thinking about this for the better part of 10 years at this point. In 2017, there was a seminal paper that came out called Transformers Are All You Need, or sorry, excuse me, Attention is All You Need, that described the transformer architecture, which is really the underpinning of large language models. They are very good at specific things. I use them all the time. I'll give you an example. I had to do some interviews recently, and I asked ChatGPT to generate an interview question for me, and it did. And I wanted to be data-centric. And then I asked it to generate some Python code that would make a fake data file that was 10,000 lines long that we could use. And it did a great job. And it was fantastic. It would have taken me 4 or 5 hours to come up with this that I came up with in 20 minutes. When we think about LLMs in products, I am always nervous. And the reason I'm nervous is because we're in the top of a very big hype cycle right now. A lot of these companies that you see up here, well, maybe not up here, but a lot of the companies you come across are going to die, right? And so being careful about how you invest in LLMs and do it in a way that is customer centric is key. We don't want to just put a chatbot, or I don't want to just put a chatbot on my product because I can. I would do it if maybe I was a company that integrated with Zendesk. But figuring out how to do this is crucial. And one piece of it, thing that I found very useful recently is this rise of vector databases. All modern LLMs that I know of are made better by the use of this new technology called vector databases. If you guys haven't encountered them yet, I would encourage you to. The way that they work is during the process of understanding content, so this would be mainly images and text, data scientists create what's called an embedding. And this is a representation of the information. And it turns out that we've gotten very, 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 very good at creating fixed length vectors. So that may seem complicated, just 50 floating point numbers that exist. And then other vectors that have semantically similar meaning are close to it. So for instance, images of dogs in vector space may be close to each other and farther away than images of cats, and very much so farther away than images of phones. And this has profound implications across a variety of products. We use it in a lot of the companies that I work with today. But as we talked about, LLMs can't do everything. They aren't some magic box. They can't just solve your problem. So please treat them as a tool, not as a solution. So some takeaways. We talked about defining the problem and success up front is crucial. And we did an aside on metrics. I could do 20 minutes on metrics easy, but spending a lot of time making sure that the problem you're solving is valuable, that you have a good understanding of quality and a good correlation between what you're modeling and the value providing to the customer. Say number 2, get better training data. I don't care how good your training data is, get better. Always worth the investment. Better data always wins. Setting up the right team structure is hard. Conway's law, in my experience, has always applied. So think strongly about not the organization you have today or the software you have today, but think about the software you want to have in the future. When you're a data-centric product manager, get in the weeds. So learn SQL if you don't know SQL. Learn how to interact with your data through your BI tool. Be curious. Right? One of the best traits I found about data-centric product managers is they come to me and say, John, did you know this about the data? And usually I didn't. And I think that's very interesting. We talked about getting the right label data as everything. Try and define success up front, but be flexible. What I mean by this is it's very common to say we have a North Star. And then as you start to optimize that, you realize other things that are happening on the side. So you want to be diligent when you're driving data-centric product teams, but still be aware of the customer value and pivot as needed. And the field is moving faster than ever. Please, 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 please try out LLMs, but do not live and die by them. That's all I have for today. Thank you so much. Happy to take any more questions. Yeah.
Amazing. Thanks so much, John. Looks like there was a lot of engagement in the chat. Does anyone have any additional questions for John?
Oh, thank you very much. please feel free to hit me up. You can find me email, you can find me on LinkedIn. Happy to answer any more questions for you guys in the future too.
Fantastic. All right. Well, thank you so much, John. This was like great storytelling and insights on how to run product teams. And I know for sure that I learned a lot about all these different data roles. So yeah, really helpful.
Thank you. It was a pleasure being here.
Thank you, everyone, for joining.
Bye.
Good night.